In the second half of this unit, we're going to talk about solving systems of equations using matrices. So for example, here I have this 3-variable equation. I could solve this using substitution and elimination, but it would be really complicated. It'd be a lot of steps. So something that could be a really useful tool to solve any system of equations is by using something called a matrix, which for this system would look something like this. So by definition, a matrix is a rectangular array of numbers. And how we use it is we can use a matrix to represent and solve a system of equations without writing any variables. So what I'm really just going to be focusing on is the coefficients in front of those variables. So for example, here I have matrix A, which we see has the elements 2, 4, 1, 6, 5, 3. What we're going to focus on to name this matrix is its number of rows and columns. So this matrix has 2 rows and 3 columns. Since it has 2 rows and 3 columns, we would call it a 2 by 3 matrix, and how we could also label it is writing it as A 2 by 3. More specifically, each number in a matrix is a matrix element. So we're going to use the rows and columns again to identify what number we're talking about in a matrix. So for example, A1, 2, we would want to look at row 1, column 2. So row 1, column 2, that number that would be in that place would be 4. So A1, 2 in this matrix would be the number 4. Next, we're going to talk about representing a system as a matrix. Here we have the system of equations x plus 3y equals 7 and 3x plus y equals negative 8. So again, what I'm going to focus on here is the coefficients in front of each variable. And as a good rule of thumb, like in that first equation, we just see an x. Whenever you see the variable and no number in front of it, that means that its leading coefficient is 1. So for my x values, my coefficients are 1, 3, so that's going to be my first column. My second column will be my y coefficients, which here is 3, 1. And finally, my constant numbers at the end of those equations are 7 and negative 8. So I'm going to rewrite this as a matrix as 1, 3, 3, 1, 7, negative 8. And sometimes in a matrix, you'll see a vertical bar between that second and third column. And what that means is it just represents the equal signs that would be in each equation. Finally, the last thing that we'll talk about in this video is how to solve a system using a matrix. Now, when we do this, we could learn how to do this by hand, but our calculator can actually do this whole thing for you, so we're going to focus on that in class. Here we have the system of equations x plus 4y equals negative 1 and 2x plus 5y equals 4. So before I do anything in the calculator, I'm going to want to write this as a matrix before I plug it in. So as a matrix, focusing on all my coefficients, I would have for my x values 1, 2, my y values are 4, 5, and then finally my constants at the end are negative 1, 4. From here, what I need to do to be able to solve this matrix is get it into something called reduced row echelon form, which looks something like this. You have kind of the ones going in a diagonal line starting from the top left corner, and basically why you want it in that form is that it'll say 1x, or just x equals whatever number that is. Your y value, or your next variable, will equal this next number. If you had a z, that would go here, and that'd be like your next number, and so on. Again, there is a way to do this by hand, but our TI Inspire will actually do this whole thing for us. So what we'll want to do to get this into reduced row echelon form is in the TI Inspire, you'll do menu 7, that'll have all your matrix calculations, and you'll press 5. From there, you'll see REF, which means we're going to get this into reduced row echelon form. In the parentheses, we'll press menu 7 again, and then we'll actually type in our matrix. If we did that and pressed enter, we would get something that looks like this. 1, 0, 0, 1, 7, negative 2. So how I would want to read that is I would see that x equals 7 for this system and y equals negative 2.